Welcome back, Science 7. Today we are continuing and hopefully finalize our chapter 1.2, which was about sudden Earth events. A little quick recalling. Last time we learned about earthquake. We also learned about various important section of the earthquake, like what was the focus, fault, epicenter, and so on. Type of the fault, normal fault, reverse fault, and at the same time, we also learn about devices that measure the earthquake, which is seismograph. Today, we're talking about other type of sudden earth event, which you already may know, volcanic activities. Before we getting into, let's go through some science log activity number 6 that I assigned. When it comes to textbook 1, like I mentioned last time, visit my Google Meet session if you have any question. Let's go through the P wave and S wave. P wave, ladies and gentlemen, first of all, it happened as a first. S wave, secondary. First wave and second wave. When it comes to P wave, they share a same direction. What I mean by that is the location, the movement of wave actually overlap with movement of the earthquake. On the other hand, when it comes to S wave, they are not same direction, they are 90-degree direction. What I mean by that is your wave may go west to east, but in fact your earthquake is actually going like this, which is up, down, and up situation. The amount of energy that you need to have it in your mind is S wave have high destructive energy. When it comes to P wave, not as much of energy that is being sent. So have that in your mind. I cannot draw arrow for some reason. There you go. Those are the properties. Determine which wave would damage the city's structures and building. Well, when it comes to destructive energy, I told you energy amount for P energy, energy amount of secondary energy. Secondary energy is way more. So more destructive forces will be the outcome for the secondary wave. Today we're learning about the volcano. Today's lesson will be shorter compared to the other ones. Volcano, by the definition, is any of an opening in the Earth's crust that releases lava, steam, and ash particles when it erupts, which means it becomes active. There is an active volcanoes and volcanoes that is in the sleeping period, but one thing that I want to point out about volcano is there's always a possibility if the lava will be coming out. And by the way, the difference between magma and lava is magma is underneath, lava is something that flows. So because it's an opening directly connected from mantle to your earth crust, it can be oceanic plate or continental plate, there is a possible danger. And generally it is quite often around the Pacific Ocean plate. The opening is called vent, and vent, you can see it from this diagram over here too. This is basically what I meant by vent. In the sea, near the deep trench, they have a deep sea vents available too. When the volcanoes are not active, aka sleeping period, we call it dormant. For example, Fuji Mountain in Japan should be in the dormant period, but I heard that some of the researchers saying it's gonna be active again and so on. So it is temporary for some, permanent one, you gotta search one by one. So let's go through the steps. How do volcanoes erupt? Everything starts from our molten rock situation. So if you think about these area, very deep underneath mantle. I cannot write today. Sorry, folks. Mantle, those are the one that you have high temperature, high pressure environment. So that's why most of the rock metals are molten. It's not entirely solid. It's very close to liquidy solid. So the molten rock in the magma chamber actually move upward. Because the thing is, if things are melted, and you can think about that with the density situation, it becomes less dense. So the reason it's going up, so this portion over here, is because density get low. The reason or analogy that I can think of is, imagine you're boiling a pot of water. Then you may notice that bubbles start forming from the bottom of the pot, but as soon as you wait about additional minute, the bubbles come out crazy and then have the current. Imagine that situation. If things are getting pretty hot, we create a current situation, circulation. So you may notice arrow goes up like that. Solid rock then expands. The reason that it expands is again because of the high temperature. But as you move up, the pressure goes down. So when it comes to this area, pressure goes down. Because there's not much that holds you or not much that stack you like a sandwich. So solid rock expands. If it's expand, then think about the balloon. You're blowing air inside of the balloon more, then balloon size expand. Then eventually what's gonna happen is it's gonna explode. It's gonna explode to the weakest vent area. And that's what happened in this picture. The magma basically start to force its way all the way upward, ladies and gentlemen. And the weak spot that you see over here is the one that will start crack, and then it's gonna be the exit of the magma, and that magma will turning into violent lava. The weak spot in earth crust will be breaking up. It can be actually break more, and the opening can get worse, so vent become larger, if you will. That's also a possibility. However, what I want to emphasize is, think about this as a fault of the earthquake, if you will. Then we have our Hollywood disaster, bunch of lava, ash, particles, stone, rock, everything erupt. And when it comes to this eruption, obviously the one that you see down here, the one that flow through the gravitational force, are the one we call lava. Lava flows from vent all the way to the volcano sides, and the reason is, like I mentioned, gravitational force is a reason. And lava shoots violently into the air as a cloud of rock fragments and ash comes out. To be fair, if I tell you the real dangerous part about volcanic activity is technically this: hot ash. Ash will be mixed as a cloud with actual cloud, the cloud that you see up in the sky right now. Cloud will be the one that will be mixed with ash, and after that what happens is photosynthesis amount will go down. So that's why it's going to affect the food chain. And this is what happened. Everything that you see over this area, ladies and gentlemen, is basically the hot ash that is expanded after the eruption of the volcano. The finest ash is kind of like a dust particle. Those dust particles settle at the bottom of the slope, and they expand carried by wind because they are very light. It's gonna cause a lot of lung problem, so your respiratory system, and at the same time, it's gonna be affected for any type of biotic factors, even abiotic factors, water condition. You need to do a serious filtration process to get a fresh water. The ash will then mix with heavy rain, and it can also cause mudslide, mud flows. This can cause enormous damage to not only human world, but also biotic factors in an ecosystem, abiotic factor of ecosystem also. And this is a picture that shows you how lava actually in the end burn everything too on the way, because the temperature is easily over several thousand. So that's why when it comes to the lava, it's gonna burn things on the way. And something that can stop, well, basically the air that is contacting with the lava itself, cool it down as time go, or if there's a if it was a volcanic island, ocean will cool it down almost instantly. Larger rock fragments falls near the vent because it's heavy. Smaller ones go all the way further away because it's lighter. And lava and rock fragment move downhill due to gravitational force. So if this is a, I think it's more of a slope, so it's gonna go multi-direction, go down like this. How the volcano erupt? Like I said, it's kind of like a expanding. It's kind of similar to as boiling water situation. Magma activity that is happening underneath of the earth crust get more violent, if you will. They heat up way more, and because of that sudden change, we are experiencing expansion that you can see down here. The expansion that you observe down here is the reason why we are, like I said, expanding the size of the balloon, except balloon is made out of rubber, so it's quite flexible. But when it comes to land, rock, mineral, metals, they're brittle, so they choose to be broken down. And it's in the end change the shape of the mountain and any type of geological structure nearby. It also causes small earthquake, depends on the size of the damage, by the way. So what kind of tool are used to measure the volcanic activity or exploration near the volcanoes that is either dormant or active? We need some specific materials. One of them is called silver fire suit. Sometimes silver fire suit is available in a firefighter station. What it does is it reflects intense temperature. If you want to know, it reflects, where is it? IR, which is infrared radiation. It's a heat wave. It reflects the heat wave, such as how mirror reflects sunlight. And geologists basically use it to make an observation, like what you see down there. I know it will be crazy, and then I would never do this kind of job in my life, but to explore the rock sample and then activity, temperature, those kind of things, people actually wear it and then move it down. Take measurement, and I believe in this situation can be measurement related, and collect gas and lava samples. What about measurement tool? Sometimes you see this on a road construction. It's very similar. Surveyor's level. It basically use it like a protractor, if you will. It measures how much angle that is changed because of volcanic activity. Because if you think about eruption that goes out like this, imagine, then the thing is you will have expansion going on down there. It's a fancy way of saying the whole slope will get steeper. because it is expanding. There will be angle change. So your job is figuring out that angle change. So that is today's lesson, ladies and gentlemen. It is a bit shorter compared to the other time because we are focusing solely on the volcano situation. I want you to, let's see, where is, I want you to work on the science log activity number 7. And as a homework question, I want you to give it a shot for textbook page 362, number 4 and 5.